Hello, everybody. This is fabulous. I don't know where you are, Rafa, but when Anna Maria and Rafa, everyone's telling their story about this, but when they contacted me to give this talk, I was so excited because trying to understand how to translate interventions that we do in controlled trials in the clinic into the community, whether it is a doctor's office or the healthcare setting, or into community-based programs, is something that we've been transitioning toward within nutrition research at the center where I am in Baton Rouge, Louisiana. But for people who don't know me, many of you may not, I'm an energy balance physiologist. I like to measure and understand how body weight is changing from an energy balance perspective. So only one of the hats that I wear is to study and understand caloric restriction. Other hats that I wear are to study weight gain. In fact, I do overfeeding studies, and we're also studying weight gain in natural experiments such as in pregnant women. But what really the claim to fame here as we think about nutritional interventions and the regulatory hurdles and the hurdles towards translating nutritional intervention has to fall on the shoulders of this wonderful trial which was called Calorie. I was an investor in the Calorie trials, both phase 1 and phase 2, and so I've spent the last 15 years thinking about these studies and writing many of the papers that are out there. So Calorie stands for Comprehensive Assessment of the Long-Term Effects of Restricting Intake of Energy. And just as a recap, because I'm not going to show data on data slides in this talk, is to remind everybody that this was the first randomized controlled trial of calorie restriction in human beings. We targeted a 25% reduction in caloric intake from day 1 that would be sustained for the whole 2-year period, and this level of calorie restriction was informed by a series of pilot studies that were done over about 6 months in duration with different amounts of caloric restriction, also caloric restriction in conjunction with exercise, and as a collective group we determined that the level of 25% calorie restriction was going to be safe in a human trial over the long term, but most importantly, it was going to promote adherence, so therefore we could really test the biology of this level of CR. The Calorie study was special, but being the first trial, we had to put various boundaries around the questions that we wanted to ask, and the main question we wanted to ask was whether this sustained 2-year trial could mimic some of the effects of calorie restriction that we observe in animals. So to test that, we made the decision to study individuals who are normal weight and slightly overweight. So you can see the BMI here of these people at the beginning of the trial was between 22 and 27.5. So these are already very lean people. And we intentionally wanted to study individuals of young to middle age. So the population, as you see, ranged from people being 21 to 50 if you're a male, but because we wanted to avoid any transition across menopause in that 2-year window, we limited the age to 45 for women. So the trial was done at 3 different centers in the US. We were one of those in Louisiana. There was also Washington University in St. Louis and Tufts University in Boston. We each randomized the same number of people. The goal was 80 each. 221 people were randomized in the trial. So the trial was very successful. We managed to only have 21 people dropping out of the trial, which is a tremendous effort for this kind of intensive nutritional intervention. And in these normal weight to slightly overweight people, at the end of 2 years, they were 9 kilograms lighter than when they started. We also just published this month a paper in Lancet showing that these individuals had a 30% improvement in many cardiometabolic disease risk factors. We did oral glucose tolerance tests in these people, but this 30% here, I was putting it from the Framingham risk score. We also showed that in support of the data from animals that these individuals had a degree of metabolic slowing. So their resting metabolic rate declines to a greater extent than you would expect based on the fact that they've reduced their body size. And that was associated with a reduction in oxidative stress that we observed at the end of the 2 years. Important, we all say we want to not only live longer, we want to live happy and we want to have a good quality of life. Many of the measurements of quality of life were increased in the people who were in the caloric restriction intervention and significantly different from those who ate an ad libitum diet over the same time. And we didn't see any decline in physical function. So I will make the point that we did observe a loss of fat-free mass. And it was more significant in men than women, but we did not see a decline in muscle strength, and we did not see a decline in cardiorespiratory fitness. And I thought that that was important to share, since we've had a lot of conversations over the last day and a half about frailty, particularly as we think about moving these kinds of interventions into older people. So as you would expect, you know, the world loves the next anti-aging thing. So every time we publish a study coming from the calorie trial, we get press out the wazoo from not only the scientific media, which is always very sensible, because usually they'll pick up the press release that comes from the journal or from the university, such as this one in Nature, makes a lot of sense. Reduced calorie diet shows signs of slowing of aging in people. But then we also get things like this: cut calories by 15% and stay young. Or this: why even slim people may benefit from calorie restriction. Cut calories benefits an already healthy heart. And this is an absolute kicker. Want better sleep, better mood, and better sex? Cut calories. I can tell you every single time that we publish a paper from the calorie trial, my inbox gets inundated with emails from people. People wanting me to people telling me their stories of their own personal experiences with cutting calorie restriction. You get dossiers of the medicines that they were once taking and now they're not taking, how it's improved their quality of life, all kinds of questions. So it seems to me that we have an important obligation now in order to inform people of how to do this safely and effectively. So what comes, based on scientific evidence or not, because this anti-aging field is so huge and something that we are trying to counteract, are tons of books. We have some books that are based on science and written by scientists, but we have several books available to consumers that haven't really been backed by much research in human beings at all. So the question really is, if we eat less, do we live longer? We know nutrition has a major part in extending health span, but we can't really answer this question yet at all in humans. So we need to think about how to do that. And the schematic that I have here on the slide is the one that describes how to translate discoveries from the bench all the way out into community-based trials and then programs that are implemented within the healthcare system. So I'm excited for the next session. So I can put a check mark here. I think that we do understand some about the biology of aging, specifically with regard to the nutritional benefits in various animal models, specifically calorie restriction and extending health span and lifespan. If we hang our hat on the calorie study alone, which I said is really the only and longest one that there has been to test calorie restriction, I'm also going to put a check mark. We see improvements in various risk factors for chronic diseases, so the secondary causes of aging. We're also seeing some good indicators that we can potentially delay primary aging with metabolic slowing and improving oxidative stress. So I think we're seeing some good signals here, so I'm going to put a check. But how do we get from this single randomized trial down now into trials that we can translate to patients and into trials that we can translate to practice? So we have a good example within the nutrition field, and that is the Diabetes Prevention Program. So those of you who may remember the DPP, this is a trial that was conducted between 1996 and 2001. 27 sites, 1,900 patients were enrolled in a 3-arm trial, control group, metformin or lifestyle intervention. But it's the lifestyle intervention that I want you to think about as we talk about this cascade of going from clinic into practice. So since the DPP was published, which was shortly after the trial was stopped in 1996, there have been a number of trials since then that have been learning how to adapt DPP in clinical settings. Then you have people lobbying to try to figure out how do you bill for lifestyle intervention. And it was only in 2018, right, in the United States, almost 20 years after the trial was conducted, that the lifestyle intervention for the diabetes prevention program became a billable service within the Medicaid program and for insurance companies in the United States. So we have a model here, I think, in which we can stand on the shoulders of to see how we might be able to translate a nutritional intervention for health span extension by thinking about the DPP. So our first obligation is translating to patients. I already mentioned that I get a lot of emails from people. One of the emails that I got after we published the paper in Cell Metabolism a couple of years ago was from Eric Liborg. And he is an associate professor at Toulouse University. He studies CR in Drosophila. And he actually wrote me a very harsh email. And he wrote me a harsh email because he told me that it was my moral obligation to address the media propaganda of the promise of CR to extend lifespan and health span in people. Because he said, we really don't have the data to be able to tell people that this is what they should be doing on their own. So he told me he was going to be writing an essay in bioessays to say that people should not self-practice calorie restriction. And he gave me some narrative of the things that he was going to write. And I actually talked him off the ledge and I said, let's do this together. So this is the result, and you can read the paper, and I'm not going to go into the specifics, but this is the concluding paragraph. We said that they should not try to practice CR on their own because for the time being, calorie restriction has only been studied in clinical trials for short periods of time and with close monitoring by trained physicians and psychologists. And his major point was, you know, this was a young population. This was a healthy population. We don't really need individuals who are 65, 75, and 85 perhaps going and cutting calories because of frailty. They already have malnutrition and so forth. So what are the next steps? So clearly we have some barriers, and I'm going to talk about 3 key barriers I think that we need to overcome in order to translate. The first one is that calorie restriction, this 25% prescription where we reduce calories, may not be something suitable for everybody. Right? We certainly can't look at the calorie trial and make a recommendation for all BMI groups and for all age groups. Think about it. The subjects enrolled in the trial were of a specific phenotype, a specific BMI, a specific age. The screening process was over about a 10-week period. None of these people were taking medications except a birth control pill if you were a woman. Nobody had hypertension. Nobody had pre-diabetes, let alone diabetes, high blood pressure, heart disease, any of these things. So we don't understand the interaction of CR in terms of various health conditions. But then once they were in the study, every single thing you could possibly imagine to measure for safety, we measured, including extensive surveillance for the initiation of eating disorders, which people felt was going to occur because now we're getting people to count calories and really start thinking about their health. And God forbid that we might change mood and increase depression and suicidal ideation. These are things that we actually followed and measured all the time. In addition, these people went through extensive testing to show that they could adhere to the rigor of such an intervention and that they were actually ready to embrace change. You cannot afford to have one sourpuss or one bag egg in the bunch of the CR group because it ruins the morale for everybody. So people like that were excluded from the trial. So the second hurdle that I see is that, and we can all nod our head, achieving behavior change is highly complex. The diabetes prevention program is very, very simple. I mean, they're implementing it as a 12-week program. There's a very specific reduction in calories. It's 750 if you're a male, 500 if you're a female, 150 minutes of physical activity. Whereas doing calorie restriction, this initial drop and sustaining is much more difficult. And what I'm showing you here is the behavioral intervention that we implemented in the calorie trial. So over the 2-year period, this is the number of interactions that an individual participant had one-on-one with a behavioral psychologist, and these are the interactions that the participants had in a group situation. So it's not a trivial thing if you start counting up the number of in-person encounters and then the number of group encounters that people had to do in order to participate and adhere to the CR intervention. So the barrier here is obviously this is going to cost a lot of money if we're going to have something to package to patients and into the healthcare system. It's also extremely time-consuming, but I can tell you the behavioral intervention was highly valued by the participants. They attended more than 90% of these sessions. The third barrier is about what we actually measure, and I loved, Nir, that in your talk you talked about what are the medical or the clinical indications of aging? I mean, aside from the safety things that I'm going to talk about in a minute, if we want to power a randomized controlled trial in large numbers of people, say an international trial, what are we going to hang our hat on as the primary outcome measure? Is it the rate of biological age? We know we have a paper from Calorie, Dan Belsky was the author from Duke, showing that we're slow biological age in 2 years. But what is the card-carrying primary outcome variable? There's a cluster of things in which we can measure. But from a safety standpoint, if we roll this out, these are the things that we measure in a clinical trial. It's not trivial, but we can't ask a physician to measure these things on a monthly basis like you would in an RCT. It's going to cost the healthcare system a ton of money, not necessarily for a physical exam, but we did EKG assessments every month because the phase 1 trials showed that some people had hypokalemia and they were at risk of cardiovascular events. We didn't see any, but we're also doing extensive surveillance for anemia. I already mentioned eating disorders. We had DEXA scans also every 3 months to measure changes in bone loss. And we were also doing one-on-one interviews every 3 months with the psychologist to evaluate depression and mental disturbance. Well, so after all of that, is it actually a safe intervention? We went to great extremes to monitor all these things, and I can tell you that absolutely yes. So there were only 6 people that were discontinued from the calorie trial. And you can see that 50% of the 6 people that were discontinued from the CR group were women because they became pregnant during the course of the intervention. 1 person was discontinued for a loss of bone, and 2 people for anemia that failed to resolve even after they were temporarily discontinued from calorie restriction. We had 1 person whose body weight dropped below a threshold that we thought that we should discontinue the CR, but then once their body weight comes back up, they're allowed to continue. Now, what about adverse events? I'm not going to show you them all, but I will tell you the most significant adverse event that was different between the CR group and the control was dysmenorrhea, or irregular periods in the menstruating women. That was it. Other than serious adverse events, no deaths. This is always a good thing. But you can see that of the 14 serious adverse events that reported, majority were in the control group, the individuals that were eating ad libitum, and of the 4, they were all the pregnancies. So I think that CR is safe, which means I think that we can implement it. We just need to get over the hurdles at what makes sense to measure, because we shouldn't be looking at the clinical trial and the list of all the safety monitoring as we did as being the card-carrying set of safety indicators if we go to clinical practice. So can we recommend an evidence-based program for calorie restriction to patients or for the healthcare setting? I think we can. Because there are two key things that you need to know if you want to start calorie restriction. The first is the number of calories that you would need to eat if you were going to maintain your weight today for the rest of your life. So we have several different equations available. WHO has some, we have some at Pennington, the calorie generated some, there are some at the NIH. And these equations can tell you your energy requirement. You can go there, they're online, so you can predict on the basis of your gender, your age, your current weight, and your height, the number of calories that your body would need to consume to stay the weight today. Therefore, you can self-prescribe a reduction of 15 to 25% because we know that's feasible, and that would be your calorie target. The second thing is that once you get a calorie target, how do you know that you're actually achieving that? Of course, you can be like the cronies, right? These are these self-practicing group of individuals, and you can have your scale and you can count calories and you can become totally obsessed. We didn't do that in the calorie trial. The best proxy for knowing if you're achieving a caloric deficit is measuring the change in weight. So in calorie, we created these normograms for every single individual. So for each person, after we predicted their baseline energy requirement and their 25% calorie restriction, we had a mathematical model that would generate this cone of adherence for us. So the cone of adherence is the blue to the yellow line. The goal for the participants was that their weight would change according to the green line. So we educated them to stay within the cone of adherence. We taught them that if their weight was above the green line, which was their goal, they were eating too much for the few days before. So therefore they need to eat a little less to get their weight below the line. I know this is very simple, but simple is what we would need in order to implement something in the healthcare setting. So we did this. So this allows for personal monitoring. It allows for monitoring easily by physicians. And just so you know now, with this technological age, we have developed this program into an app. We use now Bluetooth scales. These are scales that use Wi-Fi to talk to your phone. You stand on the scale, you write nothing down, the weight goes to the cloud, we pull it out, and we can put it on your phone. So we've worked already with companies to take this rudimentary Excel spreadsheet of a graph that we used in calorie to make these fancy apps now with the cone of adherence so that people can weigh and monitor in real time to see if they're hitting their calorie restriction target. So I do think that we can make progress, but the next step is implementation science. If we know how to improve health span with calorie restriction, we need to figure out now how to get it into clinical practice. This is an entirely different branch of science. This is getting into social sciences. It involves focus groups with people. It involves focus groups with practitioners. It involves key focus groups and meetings with various stakeholders at a number of different settings, and I think we'll hear about that in the next session. But you can't just roll out what the scientists invent into the clinic. It's just not going to work. So implementation science is what's next. So the last point that I want to make about translation is the moral obligation that we have as clinical scientists to take what we're doing here at the bedside or in these human clinical trials and translating back to the bench. And that's what we heard from Luigi, and that's what we heard from Nir. But calorie was set up in a way to provide this gift to people and for generations to come, I hope. I want you to take note of the calorie website. The calorie investigators are still very active. We have a steering committee. We have an advisory group. Roz Anderson is a part of our advisory group. We have made the data from calorie publicly available. Any person can go here. You can navigate on the side. It says about the database. You just register your information. You can download the entire set of calorie data. You can do whatever analysis you like. You can publish the papers freely on your own. The data dictionaries are there. But even better than that is that in this study, we collected thousands and thousands of samples. So we have, I've put a list here, but on the website you can go and see the actual number of samples that are available for each of these human biospecimens. We hear the difficulty of collecting specimens in human subjects, but we even have tissue samples available. We've already got RNA extracted, we've already got DNA, so we've got a number of different materials that I encourage our seasoned investigators and our upcoming investigators to make use of this. We have a procedure. You go in, you're going to just write a very brief proposal of what it is that you would need. We coach you on really how much you need, because sometimes people say, I need like 5 grams. And we're like, no, you don't. You really only need 0.5 milligram. So we will coach you, and then once it's approved, you'll have a letter of support for your funding body, so you can get funding for the secondary analyses in calorie. So I'm going to wrap up by saying that I think it's very clear that not only in this room, but worldwide, people really are still chasing the fountain of youth. Not only do we want to live longer, we want to live longer more healthy, and we want to live longer happy. So I think that there are 3 things that are on the agenda for clinical research. I think that there is scientific value in establishing an international cohort of people following a CR intervention. I think that this cohort should be established early age, and that they should be followed for, their life. So this is a study that will extend far beyond my time on the earth, but I think that this is a good time to start thinking about what would that look like on an international stage. I also think that we've got enough evidence now in young middle-aged people that this intervention has a lot of promise. So I think that the implementation science can start occurring for thinking about how we could package and roll out something for young and middle-aged people. But I think that it's too early to start making recommendations for the middle and older members of our populations and communities for undertaking calorie restriction interventions. For example, we know physical activity is extremely important for preserving mitochondrial function, for maintaining physical function and preventing frailty, but physical activity or exercise wasn't a part of the calorie study, but it may very well need to be part of an intervention that's initiated in middle or later life. So RCTs are needed here. I can tell you that we are developing something now in cooperation with the National Institutes of Aging, and it is a time-restricted feeding intervention that will be in 50 to 80-year-old individuals. So these would be people that we wouldn't be cutting their calories, but they would eat all of their calories over an 8-hour period within 1 hour of waking until 8 hours later, compared to a control group that would eat normally over the course of 16 hours. So I think that there are a number of ways to get at CR, but we don't have the answers in this group just yet. So I need to conclude by obviously acknowledging all the calorie people, because this was a tremendous effort, $35 million, I would say, on this trial, and it's the gift that keeps on giving, because these samples are available and they don't have to stay within the US. So please, if you're interested in something like this, talk to me later and I'll help you navigate how to get them. Thank you.